for this train test split, the name itself will tells you it will result in 4 variables. These 4 variables are nothing but training variables as well as testing variables. So in order to split those training and testing variables, I need to be passed the input. I need to access my input, right? So why? Because I have taken previously it as x, and y is my output variable, and I am specifying the test size. This will indicates you 0.3, right? That means 70:30 I am going for, and random state is equals to 0. So it will this as it is a function, it will result into 4 set of variables respectively. Those are training input output and testing input output variables. So if you want to know what are training and the testing input variables also, you can able to just type what are my training variables and what are my testing variables. So just type the command. So from our data set, these will be considered for training. These variables will consider you for training purpose. And if you want to know how many values they had been taken it for testing purpose, you can able to make use of that x underscore test, right? So these are my variables. So these are the data points the system itself will taken for the testing purpose, and these are all data instances the system itself is taken for some training purpose. In this manner, you can able to know which are my training and which are my testing instances. So why? Because it has resulted the same values, right? And afterwards, after we splitted it, now we split it. We got so many data instances under training section, and in testing section we got only some 0.3. That means out of I have 30 rows now. So
that splitting once, can you explain that? The splitting of the data into some percentage, is that right? Test data and
yes, sir.
Percentage as a test data and for the testing validation, that's the percentage.
Yes, I have specified it as some 1/3. No, I have specified it as test size as 1/3. Why? Because this function will take test size. Test size as 1/3.
That means one third data. That means 1/3 means test size 1/3.
Yes, one third of the original data.
Okay,
1/3 of the original data, right? Yes, anything. Right. So and afterwards we are about to apply some linear model, right? We are about to do some linear model. So import the class linear model. So under this class we have a linear regression. So it stands for simple linear regression, which can be works on some one input variable and which can be works on some training data set, right? So what are my training data set? X underscore train and Y underscore train are nothing but my training sets, right? These two are nothing but our training part. Why? Because for model prediction we require only the training data sets. So we fitted it. We fitted it. So then only when we light this line, then the bias or the weight or slope, whatever we will call, that will be get generated, right? So till we don't write this fit function, we don't get it. So when it is successful, it will tell you that output has some linear regression. I got it. So and this object I have been storing in some REG. Right now, I need to be, after I got the model, I need to be test on my testing purpose. Why? Because I have taken this X test for my testing purpose, right? So using this object of regression, I am calling the predict function for testing this X underscore test, right? So it predicted some values for X underscore test, and all these values I stored underscore Y underscore predicted. Right. So now using these predicted values, now these are my new predicted values, and the actual values in my data set is containing under Y underscore test. So those two I am about to be plot in order to find the best fit line. So those two things has to be passed as the parameters to the scatter function for finding out, right? So just I am plotting only these two. So just I am visualizing only the tested things and the predicted things. This indicates you the actual y values, that means the dependent values in my data set, and this indicates you my predicted values presented in my data set. And I'm just knowing for these 10 data instances how it is predicting, how it is scattering the data objects. So from this conclusion only we can able to derive that yes, we can get a best fit line, as because just we plotted it. And if you want to find out its y-intercept and the coefficient, it is the same as it is that I discussed in the earlier class, right? And I want to draw some best fit line. For this we use the function xplot, and then tries to derive a best fit line which is covering all these data points. So this is my best fit line, this is which is covering all my predicted values, right? And I found some data points like this and this which are away from this best fit line. So these points I should be taken care into the consideration in order to find my error rate. So why? Because my intention is to put all my data points on my data lines, but some points are been missing and it falls above and below the line. So I will consider its distances. Yesterday we talked about some R square. Using this R square technique, we can minimize, or you can use any parameters like SST, SSC, SSR. Any parameters you can make use of it in order to find out that error rate, and then again we train, and then we can able to go for the training purpose. So this is how the way we can able to check to what extent my model is being good, and whether it is covering all the data points, or whether we need to find some error rate, residual error rate, using any one of the parameter that we already been discussed in the yesterday's class. So this is what I would like to show you. How can we work on a data set that is containing only some simple independent and dependent variables, right? This is where I am been left over from. And in this class, in this class, we are about to talk about multiple regression, right? So from multiple, we will start from multiple regression. So just I am maximizing my screen. So I don't want to talk much on it, multiple regression. I will go into the statistical part. Only the thing between simple and multiple linear regression is it will vary in terms of the independent variables. So in terms of simple linear regression, I can use only one single independent variable for predicting out the respond variable or the output variable. But in case of multiple linear regression, I may have different multiple individual independent values I have, like M1, X1, M2, X2, and so on, some Mn, Xn. So, but there is a, how can we conclude that it comes under simple or multiple regression means if I increase my independent variable more than one, that is from 2 or more, then I will come to the conclusion that it stands for multiple linear regression. So definitely for multiple linear regression, the minimum number of independent variables should be 2. It should not beyond be 2. It should be greater than or equal to 2. So then we can able to find out these dependent variables for predicting out the same thing. Here M1, M2 are nothing but the slopes or coefficients, whatever we will call. We need to know these M1, M2 and M3 in order to best fit our line. So until and unless we don't know M1, M2 and M3, anyhow X1, X2, X3 we will be get through the data set, but we are about to intended to find this M1, M2 and M3. So using these slopes, we are about to best fit our line of my dependent variable. So we will say how can we derive these M1, M2 and M3. So now we will take the same example. Let us say we consider only 2 independent variable case here. I told you if I contains 2 independent variable at least, then I need to deploy multiple linear regression model, and this is my output variable, as because it is my supervised learning technique. Definitely my input and output has to be present in my data set. You consider for the case where the y values are like this and x1 and x2 or like like this. Now I need to find out the best fit line for on this particular data set. So I can make this equation like y is equals to m1x1 m2x2 and so on, some bias. So coming to this particular slide, in order to find out this m1 m2 m2 and so on, some mn, what are the necessary parameters that I required first? So how can we conclude that I need to do this like x1 square, x2 square, x1 x1, x2y, x1 x2? How can I will comes to know all this? In order to understand these, how can I understand these parameters are been required in deciding the values of m1, m2 and m3? So we have I will show you one more slide for understanding this purpose, which I can scanner it. So this is how the way we can able to derive. How can we will come to know this? For example, say our multiple linear regression will always takes the form of like this. So here we will consider this is the bias, and this is m1x1 and m2x2. So how can we know? Means just we normalize it. How can we do? How can we perform some normalization? Means take summation on this y. When you do summation on these both sides, the values that I will be get is summation a plus some b into summation x1 plus c into y, because all this a, b, c are constant, so we can put a part of it. And summation a will stands for, it indicates you I is equal to some 1 to n. It indicates for all the variables. I am considering it for the case of a, so I need to be consider all the n values. So na it will becomes. In the same manner, I need to do x1 with y. Why I should do? Why? Because my multiple linear regression is taking the form of x1 and x2. So I need to be multiply. I need to derive these x1 and x2. I need to find the coefficients like m1 and m2. In my case, b and c. In order to find b and c, I need to make use of that input variable called x1. So I am just multiplying this same y with this x1. When I multiply this y with this x1, I will get a into sigma x1 plus b into sigma x1 square, sigma c into sigma x1 x2. In the same manner, go for x2. When I go for it x2, I will get when I multiply with the same equation with x2, I will get a into sigma x2 plus b into sigma x1 x2 plus c into sigma x2. So now I got these normalized equations. So what I need to do, my intention is to find the values of a, b, c. In order to find the values of a, b, c, I need to solve these three equations. So how can I solve? In order to solve this one, I need to find the values. I need to find the leftover parameters. So what are the leftover parameters I need to be find? In order to find ABC means I need x1, sigma x1, I need sigma x2, I need sigma x1y, sigma x1, sigma x1 square, sigma x1 x2, sigma x2 plus sigma x1 x2 sigma. So these are all the parameters that I require in order to find this ABC. So that is the reason in my slide in my slide I have shown to I need to compute all these values. When I compute all these values and if I substitute these values in these equations, then I can able to find the values of A and ABC. For example, say, how can I find ABC means, if you are familiarly with the touch with the linear algebra matrix calculations in finding ABC, it is as it is like this. For example, say I have taken one example for solving this ABC. For example, say after evaluating some sigma x1, x2, sigma x1 square, I got these values like this. Just I substituted like this, and I am naming it as this one. So you can use some substitution method or cross matrix multiplication method. How can we solve ABC? In the same manner, we can able to solve this ABC. So it is very simple for finding out. So that is the reason why I have taken all these parameters. So if you see I computed sigma x1, sigma x2, sigma x1 square, sigma x2 square, sigma x1y, sigma x2y, and sigma x1 x2. So taking this x1 and x2, my intention is to find out the normalized values for this data set. Once I got these values, then finding the slope of M1, M2 and Y, so sorry, C, that is nothing but bias. It is very simple. So in yesterday's also one of madam asked me how can we find C in linear equation. By the time I didn't strike my mind, it is very simple. So Y is equal to mx plus C in case of linear regression. No, so when I put C apart, I will move mx towards left side, then it will becomes Y minus mx. In the similar manner, substituting the values of Y and M1 x1, then I will get the value of this bias. So here also the bias is nothing but mean of this Y minus M1 into this mean of this x1 and M2 into mean of this x2. So this is how the way I can able to get this bias value, and these are the formulas that can be used using whatever the parameters which I calculated earlier. Using those parameters, we can able to calculate the values of M1 and M2. So these are all the parameters, right? Once we got these M1 and M2, then keep on substituting those values so that we can able to get the expected best fit line. So I hope that you just substitute the values of sigma x1 square. What is sigma x1 square? What is sigma x1 whole square divided by total number of the elements? This is capital N. I have taken the entire population, not small n, right? Why? Because mean I am about to calculate it. Right, so just keep on substituting all these values, then we can get M1 and M2 like this, and the C is this one, and just substitute those values for finding out the best fit line. So on substituting this value, I will get 1.736. This is how the way we can able to do in case of linear regression, right? So then coming to the process of multiple, very easy. Only the thing is we need to be undergo for some 3 steps here. So what are these 3 steps? Means in the first step we will go for data pre-processing, as it is anyhow in my data set I don't require any kind of data pre-processing. I have taken the normalizer and the full-fledged data, and import the libraries as it is, and import the data set which you want to perform on some multiple linear regression. But here one important difference or one important thing that you should be consider when you are considering some multiple linear regression. Your multiple linear regression maybe contains some categorical data. If it contains some categorical data, then you need to encode it. So that this is the only change that you need to be maintained in multiple linear regression. So that means if I find some names, I need to be converted into some encoding scheme. Like I can make use of one-hot encoding or some label encoding schemes. These are the different types of schemes that we can able to encode the categorical data, and avoid the dummy variables. These dummy variables are nothing but the variables that are going to be get after encoding my categorical data. Then we need to avoid all this. We need to be avoid all this whenever we are about to train my data set. That means whenever we are going into some algorithm for splitting purpose, like for training and testing purpose, we need to avoid those dummy variables. So then we can able, after avoiding it, then we can get the original data, and the next process is same as the case with the linear regression. But instead of linear regression, here you need to be apply for some multiple linear regression for obtaining the model using training set, and then you can able to cross validate it using some testing results. Right, the same process you can able to do it. So for better understanding of this process in multiple linear regression, we can once again see one example program on some multiple linear regression. Right. So So here, this is an example of showing multiple linear regression. So here I have taken one data set called 50 startup. All these data sets you will find in some Kaggle.com or some YouTube. If you go through it, you can able to find all these 50 startup. What is the main purpose of behind this 15 startups CSV? That's what we should understand here. So see, in order to understand what data it actually contains, I'm just printing my data set. So when I print it, see my data set is going to be look like with various attributes, R&D, spend. These are the feature names or the attribute names: administration, marketing, state, and profit. Here my intention is to find the profit that I will be get on putting investments on various areas, various sectors like this. So for example, say this will indicate you. For example, if I put this much amount on R&D and this much of amount on administration and this much amount on marketing and state, even for the state also, if I put these as the input things, this is the profit that I am about to earn. So like this, it has been shown for 50 startup companies. So I think why I have chosen this example means any company is about to put as a startup, and if it wants to know, to predict how much profit that I can able to get, this is one of the linear model that can give you some kind of knowledge to them, so that they can able to put according to your investment, you will get the profits, right? So I applied different sections like this. You can take many number of attributes, whatever you require, but only the thing in case of multiple regression that you should understand is if we keep on increasing some x1, x2, x3, and so on, some xn, its complexity will be grows as usual, right? I need to find all these values. Anyhow, we are not doing, right, and the system will do it using some predefined functions. But only the thing is, for analysis purpose, it will take you some time, right? So this is about my data set. So my intention, this is my dependent variable here, and I will consider all these are the independent variables. So, and here if you see my state, it is a attribute that is a categorical attribute. It is. So now, as we seen in the process, if any such kind of categorical attributes is present, I need to be convert for one-hot encoding or some label encoding. So I should come to know that what can I do, whether I can able to be go for one-hot encoding or label encoder for this attribute. In all the remaining cases, we have numericals, no problem. We can directly multiply or do some additions, calculations, and all. But only with the case of state, we need to explicitly focus on it. So how can we do? Which kind of encoding technique is most preferable for state? In order to understand this, if you just glance at my data set, it is containing different states like California, New York. These are the various states.
So what is the categorical data?
Yes, that's what I
the
would
state
like to
is No, is the state a categorical data, dummy data? What is it comes under the values of the state?
It is a categorical data. Why? Because I find unique names. How can so two kinds of data we may be encounter normally, that is nominal and ordinal. So these in case of qualitative, this nominal and ordinal comes with nominal categorical and ordinal categorical. How can I differentiate whether it is a nominal categorical or an ordinal categorical means? The reason is very simple. Only see, if you see only names, unique names, if you identified only unique names, and if you don't make any kind of comparisons, then it comes under nominal. Then it will only names. So for these cases, we can make use of one-hot encoding. For example, if it is ordinal in the sense means we can see names, but we can make some comparisons. For example, say, if you take some size of a shirt can be some ordinal categorical data. Why? The size of a shirt can be some XL or double XL or small, medium or something. I can make some comparisons. But if it is unique and if I don't make any kind of comparisons, then I will consider it as some nominal data only. So from these things, I will come to know that it is a nominal categorical attribute. For this nominal categorical, why? Because I can make any comparisons. I cannot furtherly split this New York into some other like small or big or something else, right? Any state. So I maybe go for one-hot encoding it is. So in case of one-hot encoding, what can I do means I can give zeros and one. In one-hot encoding, for naming and naming a value, we can make use of 0 or 1. If in my column New York is present, I can put 1. If in my column where I will find California, I will put 1 over there. Like Florida, in the same manner, wherever my attribute will contain, in all these attributes, I will put 1s. And all the remaining places, I will put 0. This is nothing but one-hot encoding. So this one-hot encoding can be able to do in multiple linear regression using get dummies. Using this get dummies, a system call, I can able to be get what are the dummy data it is. See, what are the dummy data it is. For example, say if I write only data set, so and if I call this data set once again, I can able to be get. I need to work with all the things, right? I need to be start executing from here. Why? Because I am reading all the data sets again. See, if I don't write drop underscore first parameter, I got 3 states like this, which it maintains some one-hot encoding. So this is the reason I splitted this state attribute into some nominal categorical data. So wherever California present or New York present or Florida present, there only I will place 1, and in the remaining cells I will put as some 0. But why I go for drop underscore first as a true in the sense means, so then the reason behind this is, for example, if you clearly see here, I will if you see for this particular case 0 0, if Florida and New York is 0 0 means it indirectly concludes that it is a California. It is indirectly included. So whenever I get some 0 means the other thing will becomes definitely 1. So by that time I don't need to mention explicitly for this one. So but that time I need to be go for drop underscore first. I can make use of this attribute parameter is equals to some true. So if I make like this, I will get into the original state. I will get with only the remaining things. I will be getting drop underscore first. True is not defined. Drop underscore first is equals to some true. I think so. We need to be make use of some single quotes over there. Right. So when I call this data sets, so then I will be convert. Then I can able to be convert into some 2 states. If you required, you can go for this one-hot encoding in this particular case. After we do some one-hot encoding here, and then we are trying to print out all the values here, then what we need to do for our multiple regression, and all my numeric CSV file has been converted into numericals, then I can go for I need to tell which are my input and which are my output in order to generate a model. So I need to find it. So my independent variables comes under all this, and my dependent variable is nothing but my profit. I need to find out the profit exactly. right? So this I taken in some separate variables, and whatever the variables, whatever the values I taken in the independent variables and dependent variables, I am assigning it to some y and x. Here the next process are one and the same. So just I am training and splitting my training data set, and same process I will get some respective input to training and testing pairs here. And then I need to add some constants of I need to add some constant. These constants are nothing but some error. If you wish to add to your linear regression with some kind of error or bias, that can be accomplished with this SMA class that is present under your statics model. So just I am adding it a constant to my training as well as for testing. Right, simply just why? Because for generation of a model, before we are about to generate a model, we need to add some other extra things if you require. That is nothing but the error rate. So nothing but the intercept, like beta naught as per in your examples. Right, then I need to be run with some multiple regression model. I need to be go for some multiple regression model to have some multiple regression function. I am using OLS. It stands for ordinary least square function. This ordinary least square function will take our training data as well as our training data on X and Y. It will take both, and it will give you to a model. Once I got a model, that means I am assigning all the values to a model. Using this variable model, I am calling the fit function. That means I am about to find out M1, M2, and M3. How many slopes that we have been present in our equation, those we can able to get by calling this function called model.fit. And if you want to summarize it, call the summarize function, so that you will come to know what are whether all these x1, x2, how many variables it has, in independent variables coefficients it has, whether it tries to predict it not. So we can able to be get with this. So just scroll it down, then you will comes to know all this. So see here, these are all the coefficients that it has been find out, and this is the error rate in finding out the constants. The overall summary I got it. So just put these values in your equation in order to draw a best fit line. That's it. So it is very simple, right? Then we are working on some test data. If we work on some test data, it has to be predict some y values on my text data. So these are my predicted y values, right? And the same process, if you want, you can go for scattering it and then draw the best fit line for choosing it. This is how the way we can able to get this x1, x2, x3, and whatever the example that I have been shown, you know, for finding A, B, C in the same manner. These are ABCs. These are all the coefficients, and you will take the appropriate input parameter and then multiply it and then keep adding it in order to draw the best fit line. This is how the way we can able to do in case of some multiple linear regressions, right? So next I would like to talk about this is the overall process. The overall process has been summarized like this. So and the next topic that I would like to talk on is logistic regression. So the logistic regression is a completely different with that of linear regression. In case of linear regression, so our intention is to find some prediction on some numerical values. But when you go for logistic regression, it is a classification algorithm. So here our predicting thing is nothing but a binary outcome. It can be multinomial or some binomial. So in logistic regression, it is about to predict some binary outcome, that is nothing but 0 or 1. But how can I find it? So here, see, these are some of the outcomes what a logistic regression is about to predict you. For example, you consider for the case like I need to find out the stock market prices. I need to find some anyway salary, for example, as we consider in the earlier example. Then by that time we will go for linear regression. But whenever a question like whether rain will fall today or not, right? Can a particular person will buy some insurance or not? When such kind of questions will ask you, then the logistic regression will come into the picture. By that time, your predicting answer should be either yes or no, or in another words, it can be 0 or 1, or it can be some true or false. Right. So at this case, we can make use of this logistic regression. So it is a classification task which is used to predict out the binary outcomes here. Right. So logistic regression is a classification algorithm. It is used to predict only the binary outcomes like yes or no, or true or false, or 1 or 0. So 1 indicates success, or 0 indicates some failure. So it predicts the probability that a particular event is going to be happen. Whether, for example, if I ask you whether a particular person is going to take some insurance or not, I have to predict through my model, and I will have to tell to that person, yes, he can, as per his ages, as per his other parameters, whether he is about to take some insurance or not. These kind of predictions that you can be made with logistic regressions, right? Anyhow, we will see the same scenario when we talk with deep learning, right? There also the output should be some 0 or 1, like my model has to predict some cat or not cat, like dog or some mammal or some non-mammals. So if such kind of scenario come into the picture, then I need to be make use of this logistic regression. So how can we do it? Right. So here. So see, so this has been shown graphically like this. Like so, my prediction things should be 0 or 1, or it can be yes or no, or true or false, or high or low, or any other things. So it can be not only binomial, it can be go for even you can apply this multi-class logistic regression for sorry, you can apply this logistic regression for multi-classes classification also. So that we can able to see here. So these are some of the cases, use cases where I can able to apply a logistic regressions, right? So for example, if you consider like this, will it rains or not? So it will take some parameters like this, and it will tends to find out some whether it is going to be get a rain or not. So for example, if I ask you this question, like will a student will pass or not? So by the time I have to tell yes or no, or otherwise yes, he will pass, or he may not be passed. In such kind of scenarios, this logistic regression application will play a vital role in understanding. So what is a logistic regression, and what are the basic points that we should consider when we are dealing with logistic regression? These slides will talks about, right? See, there is a closeness between linear regression and a logistic regression, but only one thing is, in linear regression, in order to predict something, we are drawing out the best fit line, and we are about to predict some numerical value. But in logistic regression, instead of drawing a line, what we are been doing means we are fitting all of my data points in the form of some S-shaped function. So when we fit all my data points in the form of a SF function, then with that SF with S-shaped logistic function, I can able to predict whether it is 0 or 1 or 1 or 0. How can I comes to know that whether I should apply 0 or 1? So for this, what it will be happen means, so this logistic function is also a mathematical function. Similar like in linear, so that is used to map the predicted values of their based on the probabilities. So here we will use some probabilities. Why? Because our predicting thing will be 0 or 1, like whether that event may be happen or not be event. If such kind of answers has to be solved for a particular question, then we need to be estimate their probabilities. Right. So definitely our logistic functions value will not go beyond this. It can be either be 0 or 1. But in case of linear regressions, we can go for some continuous value. Your predicting value can be in between 0 or 1, like 0.1, 0.3, 0.5, and so on up to 1. But in case of logistic regression, it can be 0 or 1. And in case of linear regression, not only 0 to 1, it can be go for minus infinity to plus infinity. So that is one more difference that you have to be noted when we are applying some logistic regression on something else. right? So how can I find it? Means just the thing is, I told you we draw a S. We need to fit our data points in the form of some S-shaped curve. That S-shaped curve is also called as some logistic function or a sigmoid function. So this using this sigmoid function and a logistic function, we can able to determine what value it is. Either it can be 0 or 1. So how can means only the simplest thing. So in the next coming slides, we will see how can we make use of this sigmoid function. See, on seeing this diagram, then we will comes to know that in logistic regression we use the concept for threshold. We have to take this threshold value. So why we need to take all this threshold value means in order to predict what value our model is going to be written, whether it has to be written 0 or 1. So for this purpose we will put some threshold. If for example, say in our these are all my data points here. All these data points has been drawn in the form of some S-shaped curve. So and I assign some threshold value here, right? And I assign some threshold value. Then I will make the conclusion like this. Like if my threshold value is greater than some 0.1, then definitely whatever all the data points that will scatter in this area will be 1. Will becomes 1, and whatever the values that will comes under 0.5 to 0, that will becomes under this. That means here for this case I can consider it as 1, and for this case I will consider this it as no. So like this, or 1 or 0. In this manner we can able to predict out using our logistic regression. Only the thing is we need to have here some sigmoid function. When we got that sigmoid function, how can we comes to know all this? When we scatter it, then we will comes to know how these data points are been arranged on my graph. So by seeing that pattern, so that's what I told in the yesterday's class. There are various patterns. Seeing that pattern only, we can able to find out the mathematical function that can be applied for this model to correctly predict out the things. Either we can go for some linear regression or some logistic regression. And one more and one more reason behind why we are going for this particular case means, for example, say you consider that for example, I am just drawing a line here. What is the reason? The one more important thing beyond going this. For example, say I have given a best fit line using my linear regression. So you consider that this is my best fit line, and if I divide this into some equal parts like this. So what will be happens in case of linear regressions? We will consider both the positive and negative. Why? Because it forms some axis, right? Positive, positive, minus, plus, minus, minus, and plus, minus. So whatever the data points that I find here, that means in this first section, in this quadratical region 1. So in this quadratical region 2, I will consider all these data points. And I tends to find out here in this quadratical region some 3. Right, so like this and so on, like 4, it is some 4, right? So these are all my quadratical regions. If any one of the data points falls here or here or here, then I can able to be predicted. But in case of linear regression, what will be happens in the sense means we will take some minus infinity to plus infinity values. We will consider all these data points into the considerations. But when we used this logistic regression, what will be happens in the sense means we will consider only the points that falls under this portion and this portion. Right, from these two portions only I will comes to know that so for example, say if any one of the data points falls here, I can directly tell that if it is greater than 0.5, it is true. So I don't need to bother about this. And if any data points find here, I can confidently tell as 0.3. If I got it, I can confidently tell that the data point never meet this threshold, and anyhow this value will become 0. This is how the way my sigmoid function will helps you in determining the data points for prediction purpose. This is the basic reason behind this, why they are going for this S-shaped curve in case of logistic regressions. right? And so now I need to, like in linear regression, here also we need to be frame a logistic equation. So what can be the logistic equation for predicting out 0 or 1 or something else? And I told you anyhow, this is somewhat very closer to the linear regression here. So taking the linear regression equation into the consideration, we can derive the mathematical steps for the logistic regressions also. So its scenario is very simple, right? So we know that in our linear equation, whenever we take some line, we can able to draw some equation like y is equal to some mx plus c. Using this equation, we are about to predict out the numerical values. But now we are converting this. Now we need to be convert. Why? Because it affords to predict some numerical values. But when we talk using this equation, we need to find out, we need to derive this logistic regression equation. So how can we able to be get it? How can we rewrite that equation which is in linear, which takes the linear form in terms of logistics? So for that purpose, what I did in the sense means here we are about to estimate the probabilities whether a particular event is going to be happened or not. So I can model this equation, this statistical equation, using my predictor variable. So we will consider only the predictor variable for this, right? The basic reason is why? Because our y value you only the predictor variable. So I will think that the value of y by 1 by y, 1 minus y. This is not 1 by minus y. It is only 1 minus y. What this will indicates you means, this will indicates you whether that event will be occur. For example, say if event will be occur, I will write it as some y. My predictor variable is y. If my event won't be occurs, I will write it as 1 by y. So in this manner, my linear regression equation can be modeled as a ratio of the probability of an event will occurs with that of the probability of an event not occurs. So in this manner,
is 1 by y. Is it 1 by y or 1 minus y?
No. That's what I mistaken it. It is not 1 by minus y. It is 1 minus y. That will indicate you the probability of an event not occurs, right? If we know the probability of an event is y, the probability of an event not occurs is 1 by y, right? So I expressed this linear equation in terms of logistic regression like this, right? So this is how the way we can able to accomplish it, and later we can equate this equation to our logistic regression for finding out my predictor variables, right? So how can I get this one y by 1 minus y? So this is very simple. See here, the steps are quite simple. In logistic regression, your predictor variable has to be between only 1 and 0. So what we will do means we just divide with 1 by 1 minus y. When we divide with 1 minus y, what we again get? We will again get the same thing. We will again get 1 by 1 minus y. So this is my model equation now. So if I want to make this model to generate for 0, then definitely I need to be substitute 0 instead of y, right? So and if it wants to be for y, then I need to be substitute infinity for it. Then I need to be substitute. So in this manner, I can able to do it. In this manner, I can able to be do it. If I take y as 1, then I will be get 0 for by placing 0, and for 1 I will get for infinity. In this manner, but only the thing is it should not be go for infinity. It has to be there within a range of 0 to 1 only. So what we need to be do means just apply some logarithm on it. For converting from 0 to 1 instead of infinity, we just apply logs on both sides. When we apply logs on this both sides, so what I will be get, I will replace this event with y. I can able to replace y. The basic reason is I considered the finding of an event is nothing but my predictor variable, right? So here my predictor variable is y. So I can replace this odds with my predictor variable as some y, and this equation will remain as it is. So when I write like this, I can make this equation. I need to be equated to my linear regression. So when I apply y is equals to mx plus c instead of y, I just replace that value with mx plus c. So this is the final equation for logistic regression. So using the similar linear regression, I can able to derive a statistical logistic equation from this kind of derivations. This is how the way we can able to be predict out the logistic regression in terms of your slope and bias. So that means if I calculate, if I know this, if I model this, in other words, if I model this, then I will get my bias as well as bias and y-intercept. So we can able to be get through my linear regression in terms of logistic regressions. So this is how the way we can able to be model. Yes.
How that equation came? Log y by 1 minus y is equal to mx plus c.
So log y by 1 minus 1, y is equals to mx plus c. Here we are modeling this y, this predictor variable. So instead of this predictor variable y, I can able to be write it as here y. So when it will becomes y, then I can replace that value log of y with mx plus c. Hello. So this is how the way we can able to be model a logistic logistic regression equation using some simple linear regression. And the next one is how my logistic curve or a sigmoid curve will be look like. That means our shaped curve is going to be look like. So it takes the form of y by 1 plus e power minus mx plus c. So this is the mathematical function or the statistical function for my logistic equation curve. So how can I able to be get this function? So for stating this also, I have shown a proof regarding how to convert using this log of y by minus 1 by y. How can I convert it into some sigmoid function? So this is the proof that is been talking about on the conversion of this one. So I have taken for logistic regression for an event some data that is going to be happened or not happened, like in terms of p and minus p, that indicates you the probability of an event happening divided by the probability of an event not happening. So it's your range of values is from 0 to 1, but we need to be converted to 0 to 1. For this purpose, what you are using, you are making use of the linear, you are making use of a straight line. So the logistic regression is being derived from the straight line equations, right? So as because its range is from 0 to infinity, minus infinity to plus infinity. So how can we convert it? So here are the steps for converting that function into sigmoid function. So how can we able to do it? So just apply log for my function y, because our y is nothing but p of x minus 1 minus p, that is the probability of x. Just I am taking logarithm on for this particular side, and then I am exponenting. The purpose of exponenting is I need to be remove this log. In order to remove this log, just use a suffix exponential. When I do exponential, this log and exponential will get cancelled, and then I will get p of x divided by 1 minus p of x, which is equal to e to the power of mx plus c. Just for our simplicity purpose, you consider this equation as some y. So then it will be replaced with p of x by 1 minus p of x is equals to some y. So you just cross multiply it, then you will get p of x is equals to y into 1 minus p of x, or in another words, y minus y of p of x. So take the common factor, taking the common things by shifting the terms onto the left side. So we will get 1 plus y is equals to y. So that is equals to p of x is equals to y by 1 plus y. So now replace the value, replace the original value which we assumed for y, that is nothing but e power mx plus c in this particular equation. So and then divide with the e power mx plus c. When we divide the both numerator and the denominator with the e power mx plus c, we will get the sigmoid function as 1 by 1 plus e power minus x plus c. This is how the way we can able to be derived for the sigmoid functions, right? So this is the formula. That means if you want to do some mathematical value calculations, then we can make use of this sigmoid functions. Why? Because we need to convert the entire probability of the predictor variable in terms of this mathematical equation for finding out whether it is going to be result as 0 or 1. So this is how the way we can approach it. So simply divide with the e power mx plus c on both the numerators and denominators. I will get the final equation like this. So this is nothing but my sigmoid functions, right? So you can apply this sigmoid function. Using this sigmoid function also we can able to predict the outcome. So that also I will show you when I am telling you through Jupyter notebook. Through hand, how can we determine the probability of a particular event is going to be happen or not? Like whether
that is the px by that is px by e to the power mx plus c. No, left side when you are dividing the equation.
Yes, when we divide with this, then when we divide with e power mx plus c, we will get 1 in the numerator, and here 1 by e power mx plus c we will get in the denominator. Here also 1. Again, when we do calculations, that can be replaced with minus in terms of why? Because 1 by e power minus 1 by e power mx plus c can be rewritten as e power minus of mx plus c. This is how the way we can able to be get my sigmoid functions. So this is the value. This is the estimating value of an event, the probability of an event that can be derived with this sigmoid functions here, right? So this is about how we got this fx function is this one, right? So this is how the way, right? This is about the logistic equation and the logistic function that we use for predicting out the outcome, right? So as we already told you, not only my logistic regression can be applied to binomial, that means for determining only 0 or 1 or yes or no, we can apply this logistic regression for multi-class classification also, like multinomial. You can be applied it for ordinal data, anything. For these cases also you can be make use of. So I know what is binomial and multinomial. Like in case of multinomial, you will have another types like such. I want to find out whether it is a cat or a dog or a sheep, like different like mum males, non-mum males, and other things. If I want to do such kind of classifications, I can able to get with the logistic regressions also, right? Like ordinal data. I told you ordinal data like low or high. These are the ordinal data, right? So which can be separatable, which can be comparable, right? Like medium, low, high, all this comes under ordinal data. So we can apply this logistic regressions for all these categories of for all these categories of numerical data types. So if you just see our logistic curve, it is very simple. This seeing this figure, we will comes to know this. Once we got a sigmoid function, we need to be defined some threshold value. Once we define some threshold value, then with this the threshold value that indicates whether he is winning or losing. If winning means it will be, so all the data points will fall under this particular region. If it is losing means it will be fall under this particular region. So just using this threshold value, I can able to know like whether he will win or he will lose. If such kind of questions we encounter, then we can just simply draw a logistic regression curve and then try to predict out whether he will go for losing or some winning. And some applications I would like to talk on logistic regression, like weather forecasting, like whether today taking all these factors into consideration, whether rain will come or not. right? Like a classification of different category of animals, like non-mammals, mammals, and so on. We can make use of this classification problem, and even we can betterly apply this classification problem. For that purpose, for more understanding this logistic regression, I have given some example like this. Suppose you have owned a car, right, and you are about to know whether I need to give service for my car or not. So whether I can go for servicing it or not. So by that time, you using this logistic regression. Why? Because our answer can be either I can go for a service or I cannot go for a service. So in order to find out whether I should go for taking a service or not taking a service, you can apply this kind of logistic regression like this. So what it will do, simply it will take the data that is present in your data sets and the probability of this breakdown. So the more the probability, you need to be go for. The less the probability, you don't need to go for. That's what it will indicate you, right? So taking this information into the consideration, just I will scatter some S-shaped sigmoid function, and then I will try to know whether I can go for service or not. So how can? Simple. So see, for example, say here they had been given some constraints like this, right? For example, if my probability attains 0.5, greater above 0.5, then definitely the car is going to be breakdown, and you need to be go for a service. That will indicate you this, right? And what this will indicate you means that this will indicate some threshold. So threshold in the sense means this threshold value we can able to be get by drawing a parallel line to the y-axis and with that of the x-axis, where the point will meet. This point is called my threshold value. For example, say on all the examples I have used some 0.5. In the same manner, you can use any threshold value. Or in another words, for example, after buying a long back of 3.5 years for my cars, definitely I need to be go for a due service here. So taking this threshold value into the considerations, then I can able to determine whether I can go for a service or not. For example, if I point out if my predicted value is this much probability, like 0.29, then anyhow it is less than 0.5. That means, in other words, I didn't went for 3 more years back. So now it is in the second year. By that time, whether I can go for a service or not, if I want to be predict out, means just draw this line and anyhow and then compare with your threshold. That will makes you the conclusion no need to go for a car, as because your car is not breakdown and no more you are about to go for a service or not. So in this manner, you can draw some perpendicular lines like this. Any perpendicular line, for example, say here, and if I go for after 5 years, whether I can go for a service or not. So then I will take the threshold value. I got this threshold. So just draw some perpendicular line like this, and just come to know whether I can go for a service or not. So for such kind of scenarios, using logistic regression, we can betterly predict out the things very clearly. So this
you are telling about the breakdown, right? Something
yes,
you said servicing. What is that? So this at 5 you had drawn a vertical line. Then again at
yes. That means after I purchased a car for more than 5 years or 4 years, whether I can go for a service or not. That so at that time, what you need to do, you just draw a parallel line with that respective year, like say 4 or 5. For example, consider that for the 4th year, I want to know whether it is going for whether I need to be go for a service or not. Just draw a parallel line to the y-axis and then intersect these 2 points. The point at which it meets on the sigmoid function will tell you, right? It will give you the probability. If this probability is greater than our threshold limit, whatever I have specified, for example 0.5 in this particular case, then I will directly comes to know that I may go or may not be go. So in these cases, I can make use of these predictions, right?
Okay.
So thank you. Right, and how can we implement it in Python? Right, the logistic regression. The steps are very simple. So once we understanding these steps, we need to, just as usual, we need to take some data set, or you can collect your data set, then analyze it. That means for pre-processing, whether my data set needs to go for pre-processing or not, you can able to be attained it, and then we can able to perform some data calculations, right? We can again go for testing and training, and then we can check our model with some accuracy. So normally logistic regression will always gives you good accuracy on a small data set. Not only logistic regression, so far I know, any data set, if you take into consideration when you measure that score or accuracy, it always tends to give some 0.9 or above 1, sorry, up to 1. So that will indicate you that you are working on some sample data set. If you go with some larger data sets only, then those values will be changes, and you will comes to know that model accuracy is good or not with that particular perspective. So we will see one example on this logistic regression once again. So yes. Oh, okay. Wait for a moment. I am opening my Jupyter notebook right here. So I have taken a data set. That data set is nothing but incidence data set. Here I wish to predict out. So suppose you consider that as a data science engineer, a problem has been given to the insurance company whether a particular person will buy for insurance or not. So I have taken some sample data set from Kaggle.com, and so just import all the needed libraries what you required, like you require some pandas environment, you required matplotlib, and wherever the purpose of writing this line is wherever I want to make use of this matplotlib, you just write inline, so that this reference variable can be used in any one of the cell. That is the purpose of writing this matplotlib inline. That's all, right? So just read underscore CSV. I am reading some data set, like read underscore. I want to know what data it has first. So by calling the function df.h, I got some the first 5 rows that are present in my data set. See, it has some attributes like age and brought insurance. So for example, normally when you take on seeing this data set, by considering with the real perspective, a person with age less than some 35 or 40 may not be go for insurance, right? Why? Because they will never think of that insurance and all. But a person with an age greater than some 30 or some 35, then we are recommending them to buy for insurance. So this is some sample information that we are about to show for head section, and just I am scattering it. First, I need to scatter it. When you are scattering, you need to give the input data, and you need to give the output thing. Why? Because 2 things has to be given for scattering it. As it is a supervised learning technique, we require both the input and output for scattering purpose. See, my data points have been scattered here and here like this, right? So definitely upon seeing this pattern only, then I will get a conclusion like I can able to draw some sigmoid function, right? I can able to draw some sigmoid function using it, right? So this is how I can evolve. Sorry. Okay, no problem. So seeing it, you will come to know that I can draw a shaped curve over it, right? And what about? So you may get a wonder like, what about these? It will be tends to fall outside the function. So that's what the benefit it is. Right, so we will consider only the data points that falls within that particular curve. If you keep increasing, then we will get different kinds of shape. For example, say if I tends to shape it to from here to here, my shape will goes like this, and it will cover this point, and then I will write like this. If I want to consider only these points, then I will sketch up to this level, and then I will give the such as point. So that using logistic regression, even we can consider the other points, but that not be the case with linear regression. And anyhow, this topic has been came. One more important difference that I would like to tell you between linear and logistic regression is, in case of linear regression, we need to take care about outliers. We need to take care about, for example, if any one of the, if I draw some best fit line, and if I find these are the data points that fall above or below the line, best fit line, then I should take care those things into the consideration. But that may not be the case with the logistic regression, as because I can expand this S symbol to here to here. I can expand this. I don't want to much bother about the outliers in case of logistic regressions. So that is one more point I would like to tell you. And once you scattered it, and once if you feel that yes, I can able to get some S-shaped curve, then I will consider this as the original data set, and then I need to go for training and testing. The same case, whatever we have seen in the earlier things, right? So I used a class called train test split, and I passed these as the two parameters, the input parameter and the output parameter, and define your training size and random size. So same values I will get a couple of training input values and the testing input values. And if you want to train what values it has been taken for training and testing, just simply give this variable name. So for testing purpose, it has taken these values from our data set, and for training purpose, it has taken some other values in my trainer. I didn't did it right. Okay. So here I will do for training purpose. I can able to do so just simply what other values it has been taken for training purpose. So just when you simply type this line, I will get these are the training values it has been taken from the original data set, and these are the testing values that it has been taken from the input data set. And here I have specified the training size, not the test size, right? So that's what. So 80% should be the training, and 20% will be for testing here. So this is how the way we can able to know the training and the testing values from our original data set. And later after that, what we require the model. We need to generate a model. So simply call the logistic regression that is present under your SK library under your linear model, and then this is my model now. So when I call model with this training and when I call this model with the fit function, I need to be passed only the training data. That is the reason I passed only the training data. X train and Y train are nothing but my training data. So these two parameters I pass to my fit function for representing for generating a model. So it has outputted like your model has been generated. Once my model has been generated, what is our next step? Our next step is to be predicted on my testing X underscore test values, right? We have been mentioned some X underscore test, no? Here we have mentioned we have taken these values for testing purpose, right? So I need to predict the values for these values, right? So just use this same object and then pass this as argument, and it will tend to predict the predicted values on my testing data set, right? And in case of in case of linear regression, just we are predicting some numerical values. But when you come to the turn of logistic regression, your predicting values should be in terms of probabilities. Its value should not be go beyond 1. It should be between 0 to 1, right? So instead of predict function, you can make use of predict underscore probability function for retrieving its corresponding probabilities. Right, this is how the way I got it. See, I got it whatever the testing values it has been taken, it has been result like this. So through this data set only we will come to know this. So how can we able to come to know this? Means that makes you the indications. For example, if it is 0.5, if it is 0.49 means if it meets suppose 0.5, then here it is 1. That means the first data element, whatever it is. For example, what value I have taken. For example, say this is my first value, no, 2214. Through with this information only, I will comes to know this. So when I give this as a value, as an input value to my predict underscore probability, I retrieved 0.5. That means definitely he is about to take the incidence. It is about to take the incidence. For example, in the next case you take, so here it is returning the probability of 0.15. So that means that is the indication indication that whether he will take the incidence or if he don't take the incidences here. Right. This is how the way we can able to predict on my testing X test. And then for determining our accuracy, use the score function with this testing and X test and Y test. Using these two parameters, I have scored my model. See, my model is about it is resulting 0.8. That means okay, it is not that much good. It is good. Okay, our model can able to predict the person who can able to take insurance or not. So through this model accuracy, I can able to make use of the same model for predicting so many things. So this is
what
what
does that
the
mean?
value.
0.83 means what is the meaning? Model score 0.833 means how do you interpret?
Yes, yes. My score will always should be in terms of zeros and one only. In terms of 0 and 1. If I get 1 means those are strongly correlated. That means my model accuracy is very good. If I get beyond 1, it makes me the conclusion that my model is not that much good. I need to improve it. So that is the purpose for using this score. Using this score, we can able to estimate the model accuracy. Accuracy can be given by passing this training data set.
So that means that is model 0.8
yes,
value for all the X and Y trained data, isn't it?
Yes. So this is what the model is. So why this is for our convenient purpose, whether my model is been returning the correct results or not. If I give some input, it has to predict out the correct thing. If I give some age like 35, whether this person who is having 35 years, he will take some insurance or not. So if my model accuracy is good, then it can able to predict the right way. Otherwise, it will predict in some wrong sense. So this is for this purpose, I am using this score. Right, this is the purpose for using this my score here, and then I am just predicting out whatever the values that I predicted. No, I got it. So here these are the values, no, that I got in terms of array. Through this array only I will come to know that whether 0 indicates you won't take the insurance and 1 will indicates you will take the insurances. All right, so just I printed those values for my purpose. This is how we can able to get with that of logistic regression, right? The same manner in linear regression.
What is the DT D type something is equal to
data
64?
Data type. It is an array, no? It is an array. This is an array. So it is been telling that it is an integer array. So it results into an integer values like this. So whenever if you want to know for a particular variable in Python, normally all the variables will be taken in the form of a class only. If you want to know its data type, just to type variable name followed by D type. Then it will give you what type it is. So it is a 64-bit. I am using 64-bit machine and I am representing those integers in terms of zeros and ones. This is the case. So if you take any value, you can able to get these D types commonly. And then if you want to test, if you want to know my coefficient and intercept, the same thing. So my regression object is nothing but model. So using model dot coefficient, I retrieved my coefficient, and through model dot intercept, I get the bias. Right. This is how the way we can able to do with the linear regressions. Logistic regressions. And I already told you when I am talking about the sigmoid function, using with our own hand also we can able to predict it. Using the sigmoid function also we can predict out the outcome whether he will take the insurance or not. So just to simply see here, our you just recall our mathematical formula or the statistical formula for a sigmoid function. It is 1 by 1 plus e to the power of minus mx plus c. So just import the math library. That's all. Just I am defining a function here. So this function is about to return the value of exponential. So e power minus x. So when I give some 35 years of age, your exponential value will be around some 2.7. So 2.7 whole to the power of some 35. If I give you that value, it will return its value. Then I will make use of this value in terms of this jet. Our predicted function will be, it takes the form of y is equal to mx plus c. So those values, how I got 0.042 and 1.53 means I got in the similar manner which I did in linear regression. In linear regression, we are trying to find out m. No, this is my m. and this is my input variable which I am about to take, that is 35, and this is my y-intercept. So use these values and then try to predict out this y. So this predicted, so calling this function prediction underscore function by passing the value 35, it is resulting 0.4. So anyhow 0.4 is less than our threshold limit as per our example. So definitely from this, through with our own hand calculations also, we can able to predict we can never go for instance, as because its threshold value is less than 0.5. And for example, if I give some 43 and if I call the same function, it is returning a probability of 0.5. So more than 0.5, no, definitely this makes you the conclusion that that person is about to take the insurance, right? This is how we can able to predict the binary outcomes. So here this example is meant for only the binary outcomes I shown you. Later we can be extended it for multinomial or some, we can able to do works on some ordinal data. In the similar manner, we can able to classify whether those things are living things or non-living things or something else. So whatever the example we have been shown for. So this what I would like to discuss about on logistic regression. Yes, thank you. That's about, I plan to cover the logistic regression and linear regressions, right? So if you have any more queries, you can ask me.
So today's that slides what you have shown, that equation calculation, will you be able to sharing that?
Equation part you didn't understand, sir.
Equation derivations and all that you have shown, right?
Yes. Yeah. So that is with my own handwriting. I did a scanner. That's all.
Yeah, we could. Okay, yes, we could not write it because
slide. It is just my own preparation.
Sure. Okay.
Yeah, thank you. Yes, definitely I will send you these examples. Also, I will send you along with CSV files, right? Any other questions? I'm audible. Is I am audible?
Yes, it's audible, Chowdappa.
Sir, yes, sir.
Hope we can end the session since there are no more queries from the participants. I thank Chowdappa for giving the wonderful presentation related to the logistic regression.
Thank you, sir.
End the meeting, Chowdappa?
Yes, sir. Okay, sir. I am ending.
Thank you once again.
Thank you, sir. Thank you to all the participants who are participated in this presentation. Hope this presentation helpful for MTech for doing their projects for us, right? Thank you.